Yes, dear viewers, welcome to mathematics class, a material from Form 2, a topic known as approximating square root of a number by using Gnomos. Dear viewers, this topic is presented by Selemani Mdee, a student in Masters in Mathematics Education at Aga Khan University Institute of Education Development. What are the objectives of the lesson? We have only one objective, that by the end of the lesson, we expect the learners to know how to use Gnomos correctly to approximate the square root of a number. There are a number of finding square root of a number, but this one now is what we discuss today. Meaning of Gnomos: this is symbolic representation in mathematics which is used to be placed in blocks in such a way that it will give a meaning or a square root of a number. For example, this note there is called Gnomos, and that one also, and that one also. These are so-called Gnomos. Now, what are the procedures? We place Gnomos in the vertical and horizontal sides of the block. And then a Gnomos should be placed first at the corner where the horizontal and the vertical lines are meeting. And then look at the number which is under square root of the given number. You suggest a number which is very close to that number in such a way it will give you the number of blocks to be suggested there. For example, this one, the one which is seen here, is called the 1 by 1 Gnomos. It is only one. And this one here, this is the way we place Gnomos. This is vertical, and this is horizontal line, and it is called the 2 by 2 Gnomos, or 2 by 2 block. And then, let's see an example. For example, if you are told to approximate a value of square root of 5, what we do, here we're going to consider 2 by 2 a complete block. And then we're going to think on the other block if the numbers will be not completed there. For example, now, the placement of this will be like that. You see the Gnomos are placed from the corner. And then here, we have two complete Gnomos, or blocks, in the Gnomos, the first one and the second one. So, 2 by 2 will give you 4. 4 is very, very close to 5. So, 4 will be obtained from the 2 by 2 Gnomos. Then you add the third one to complete 1, which is remaining at that place, and then we place other Gnomos or other places by different color or different shape of Gnomos. From that, we can say that type of Gnomos are a counted one, and that one we say is extra missing, where we place so that it can give us the solution or the rational number. This is the explanation of weight. 2 by 2, we get 2 times 2 get 4, which is very near to 5, and then it's remaining 1. So we add another 3 times 3, or the 3 by 3 block to complete one Gnomo which is not there. So then, the rest 4 Gnomos are placed by different sign, as we have seen. Therefore then, we're going to say, there we have 2 complete Gnomo, remaining 1 out of 5. As a mixed fraction. If we put it into a proper fraction, we have 11 over 5, which is 2.2. And therefore, we can conclude that the approximate value of root 5 is 2.2. We can see example number 2 very quickly. Find the approximate value of square root of 17. Now this one, as usual in Gnomos, we place block number 1, that is block 1, and then we place block number 2, and then block number 3. What do you think? Can we have more than 3 blocks? Yes, because 17, the number which is when it's squared, give us a number close to 17 is 4. 4 times 4 is 16. So should we have 4 blocks? We complete the 4th block. Then how many remains from 16 squared, which is 4 squared, which is 16, from 17 is 1. And therefore we place it there at the last part. And the rest points, or the rest places, is placed by using those different colors. For that then, we can say this is 4 complete block, which is 4 times 4 gets 16, remaining 1. And then that 1, which is remaining at that block, is now counted out of the rest 8, which then we get 1 out of 9. And therefore we can say square root of 17 is equal to 4 complete blocks, and then remaining 1 Gnomos out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Which then, if you find, that will get 4.11. Therefore, approximation of 17, square root of 17 is 4.11. In conclusion, we can say for a big number, you can just go direct to the Gnomos, that last Gnomos, and you manipulate as you have done, and you get the solution. Now, this method is funny, and in mathematics teaching, especially Form 2s, we have to use things like manipulating. Students are like to manipulate things. And then it is good to use it as a starting lesson where we can capture learners' ideas. Can you try yourself for square root of 12, square root of 84, and square root of 19? I think if you follow the procedures, you get them right. Mathematics is fun. Enjoy it. Thank you very much.